And we are live. Welcome to part 11, 12? I lost track. Part something. Yeah, the V0 build slowly comes to an end. There is one thing left to do that I kind of wanted to do, but then I never really took the time to do it. And that's input shaper tuning. So today is the day. I don't think this will take all too long, so I also have a couple of more things prepared for us to do. Also maybe to do while we are waiting for some test prints to come back. Yeah, so let's quickly go through the plan. So we have firstly a little bit of a showcase piece to just illustrate the problem. I have quite bad ringing on the machine. Yeah, it's quite clear, you can see it. It's quite extreme. So hopefully we get rid of that. I also prepared, actually just finished before the stream, like a repeatable demo print. Also here you see there's a lot of ringing going on. So basically we'll do the input shaper tuning, and then we will just reprint this exact G code. So that would basically be one part we want to do, but here is more. Yeah, that's maybe a quick fun story. So this is the POM nut that sits on the back edge of the bed, where the lead screw basically goes in. And I noticed, I mean, not really a lot. At first, I noticed there was quite a bit of play, when you lifted the bed a bit, there was a lot of play. But I wasn't worried about it because I haven't had any issues. And then at some point, the bed failed to home. Basically the motor just, or the lead screw just seized up. And I moved the lead screw manually with my fingers up and down a bit, and that was fine. I did one more successful print, and then, yeah, basically that was it. The bed basically just fell on the lead screw, and if you look here, it's a bit weird to see now, but there's no, you see, there's no threading whatsoever left. So basically what happened is that this POM nut is completely sanded down basically. I was able to order replacements from Amazon, which arrived next day, so that wasn't a big deal. So I bought 4, one is in a printer, 3 are here. They're super cheap, which is good, but just in comparison, you see here there's the threading, and here with the broken one there's nothing left. Hi Alex, I'm just showing off my little adventure here. So this is new, the new POM nut, and that's the old one. So yeah. There was 100 hours of printing. I hope the new one will hold up a little bit longer than 100 hours. So, yeah, that was a little bit sidetracked, but yeah, today input shaper to get rid of all that nasty ringing. And then as a small project on the side, last week we upgraded to the V0.2 R1, which comes with this nice little filament runout sensor in the rear foot. What I just noticed from myself, I always have to open the web view to unload the filament, which is quite annoying. So I want to add a little button to the foot itself, and I have a couple of options here to do that. But basically, you just press the button, and then based on the runout sensor state, basically filament is loaded or unloaded automatically. That's quite different. The SB front looks cool. Yeah, I'm not super happy with it. You see the black completely washed into the yellow one. I definitely have to reprint that, but this will be the first working version I will use. I mean, it's technically okay, it's just visually not super nice. But that's the design I want to go for, just with less washing there. Cool. Yeah, let's just start with the input shaper, I guess. So, get rid of the watch. So So just again, like to quickly show off like where we start. So this is like the test print I just did before the stream. There's tons and tons of ringing. The washing is what makes it look wild. Yeah, maybe. I mean, I also like thought about it, like it's kind of like a style. But I still want to have like another one where it's like clean. Like I mean, this is for the switch wire I want to build, and the switch wire is supposed to have multicolor anyways, like with 2 extruders. So I think this would be like a perfect like piece to print like once the switch wire is printing, so it can print its own tool head basically. Yeah, let's just. I mean, first let's turn that thing off. And then the only thing I know so far is that we have to use this little cable to connect the ADXL sensor that's included in the toolhead board to the Raspberry Pi. But it's pretty much all I know so far. And from there on, we kind of have to figure it out on the fly. Yeah, that looks like the connector here. Really cautious with those. And then I guess the cable has to face. I'm never sure with those, but I guess the blue side faces out. Alright. Kind of have to move the camera, but that's a bit awkward now with the hat open. I guess it's connected. There's not really like a satisfying click or something. I guess it's in. Like it looks in. Like it should be fine. So that's one side, and then I guess for the other side, first that we need to take off the back panel as per usual. I will leave the cable attached to the Pi and somehow stow it somewhere to the motor plate. Yeah, I also like heard a couple of people do that, because then I mean like you can just like rerun the input shaper tuning whenever you feel like it in the end. And you will have to rerun it whenever you change something on the tool head itself, right? Or like also like if you move the printer to a different like surface. So right now like I will tune here on the table, but once that printer is done, it won't stay here on my table here. So I will have to rerun that as well. So I think like keeping the cable around is most likely not the most stupid idea. That might be something I will do as well. I mean, technically it's like very thin cable, right? Like it's like really nothing. Like if you can just like squeeze it through somewhere, which I guess you have to do anyways. Actually just... I just pull it through the gap here and make sure to leave enough length so it can like reach everywhere. And then I guess for now this is fine. Yeah, on the Pi, this will connect to this little LDO thing here. Yes, also the blue side faces out. Yeah, that's easier, easier to connect. Cool, I guess. And technically there would already be like the hardware setup we need to do for that. It perfectly fits the whole of the motor plate. The whole of the motor plate. You mean back here where the bone tube goes in? I'm pretty sure it would fit there. I mean, like technically you can also just like pass it behind the, like there's like a gap, I guess. I mean, this cable fits through any tiny gap. It's the same what we did with the camera cable here, right? Like we just pass it through the gap between the extrusion and the back panel. No, the front hole. The front hole. Huh. Oh, you mean this one? Here? There's the gap. But yeah, I guess there will be like many ways to route that cable. Let's see. Cool. I guess we can turn it back on already. Oh no. I lost the cable. 1 second, I have to grab the cable from the floor. Be right back. I need to anchor that power cable somehow. It's always falling down every stream. Let's see. Did I turn it on already? No, now it's on. So let's see. I will kind of position the printer where it will like live for next week or so, which is like kind of like here the back edge of my table. So we can tune it here. But overall, like besides the missing input shaper and that POM nut disaster, it's a real trooper. Like I was printing a lot with it. First the Gridfinity boxes, and now I started printing the switchwire parts. And like it's just churning out parts without any trouble. Like you just send it to the printer. Like I had continuous issues with the Z offset, but I think that was just the POM nut causing issues. But besides that, like it's printing, which is really nice. Really nice. Like it's really reliable. No complaints. See if this is already up. Yeah, here we are. Okay, cool. Then we should also be able to. Oh, that's for later. Where's my terminal? Here's my terminal. We should also be able to connect to it via SSH. Because I assume we will need to do some SSH stuff in a second. Cool. Then let's read what to do. Because I have no clue. Oh, why does it switch to this one now? Here. Resonance compensation, Clipper documentation. I'm really curious if input shaper will handle the angled top head PCB. That's a good question. So you mean like if you open the top head basically? Oh, sorry, tool head PCB. I read top head. Yeah, like I'm also curious, but I think it doesn't really matter. That's like because the tool head PCB, just so everyone is like aware of what we're talking about. Like you see the tool head PCB is like angled backward basically, by like I guess like 20-ish degrees, and that's where the motion sensor is on, right? So technically for the movement, there's a little bit like of an angle in there. So curious to see whether this has any impact. I guess not, because like LDO, like we can also check the LDO docs actually. We can also check the LDO docs. I know in the wiring guide they mention it. If the LDO docs load up. Oh. Well. Here, this link works. Exactly, they mention here the ADXL port, and then setup and tuning. That's sensorless homing, initial startup guide. I know they mention it here. Input shaper tuning, here it is. Let's see, the LDO page seems quite slow today. Let me also just pull the laptop a little bit towards me. Yeah, exactly. So it's a mini stealth burner, but this one is for us the relevant one. Oh no, they have an external Ah, that's not like external part you can print and attach. No, it's not what we want. I know they also sell a separate like kit. That most likely will be this one here. Software installation, and then I think they sent you to the Clipper input shaper, yeah. So it's just sent you like from the 0.2 wiring guide directly to their like general like input shaper kit, and then from there to Clipper. So it doesn't seem like that there's anything special you need to do. Yeah, let's try and see what happens. But I think we're already here in the right spot. So let's just install NumPy. Let's see. Let's just install it. Yes. And then what? Oh. Sometimes it's switching randomly to my first talking head scene. Weird. Okay, while it's installing the background, let's quickly see. Next in order to install NumPy in the Clip environment, run the command clipenv. Okay, so that would be the next step. And then note that depending on the performance of CPU. Oh, 10 to 20 minutes. Oh god. Oh yeah, NumPy is always super slow to install. Okay, let's see. Let's see. This is done. Yeah, it's switching like to this like talking head scene randomly. Like I don't do that. Interesting. Well, let's see if that keeps being an issue. Why did it stop? Let's see if it now completes. Installing collector packages NumPy. Okay, so this is not a step that should take a while, but it's done already. Okay, I'm not complaining. I'm not complaining. If NumPy installs that quick, then I'm happy. Okay, so this is fine then. Okay, so configure the ADXL345 with Raspberry Pi. I assume there's only one ADXL, and that's the one we have, but I'm not certain. Hi Lars, welcome to the stream. Cool, so then I guess we just have to configure this in the printer config file. Let's just copy that for now. It's advised to start with one probe point in the middle of the print bed, slightly above it. Okay. I'm not quite sure. Let's just keep the example config like this here. So let's go here to printer config. And then I guess we can just add it to the bottom somewhere. Maybe LDO already has the configuration file. Yes, I that's a good one. I tripped over that like multiple times before, that I tried to add something to configurations that were already there. But I don't see any ADX. Yeah, switching like randomly to the scene. I don't see any ADXL in that. Let's search for resonance tester. No, it doesn't say. Oh, that's annoying. I think it's always when I paste something, it switches. No, oh god, let me quickly fix it. When I hit the delete button, it switches to the scene. I think I did a mistake when mapping my keyboard shortcuts. Let me quickly check my hotkeys. 1 second. Oh yeah, indeed. That's exactly what I configured here. How can I delete it? Now it's on escape. Okay, interesting. Okay, I'll now map it to Control-Shift-S. So let's not use Control-Shift-S. Okay. Technical problem resolved, hopefully. Let's see, can I... Yes, I can delete stuff without switching the theme. No, but there's nothing configured here. Don't save. Is there anything else here where this could be configured? Nevermore is what I created. Moonraker is Moonraker. Mainsail, macros, crow's nest. No, I don't think that's... Doesn't seem to be here then. Doesn't seem to be here. But then let's put it here in this, like, below the printer. Let's put it below. I do think I did configure the MCU Raspberry Pi though. No, it doesn't seem like. I would have put it here most likely. So this would be then the clipper host as an MCU, I guess. And then we have the sensor RPI none, which I guess I don't have to understand, but it's fine. Let's create a section like that. Okay. I'll just keep that as is for now. Let's do save and close. Configure with Pi Pico. That doesn't affect us, I guess. We don't have a Pi Pico. Oh, so now it's different sensors. But it also doesn't affect us, right? Like for us, only this section here is important. ADXL345 with Raspberry Pi. Yeah, I think that should be it, right? So we can on the side. Oh, you don't see it; it's behind the thing. But like on the side in the index, we can just skip to measuring. For non-backspad slingers, one accelerometer octoprint. Well, for us not octoprint, but accelerometer query. Okay, then let's quickly because we just saved. No, we didn't restart. Let's restart. Let's see if that already is picked up. That would be easy if that would be all the configuration. The Clippy host software is attempting to connect. Please retry in a few moments. Let's see. Ah, that doesn't look good. That doesn't look good. Let's see, firmware restart. No, doesn't seem to come online. It also doesn't give any error. Okay, what does the log say? Oh, it's a massive file. MCU Raspberry Pi, unable to connect port, no such file directory, temp clipper host MCU. Okay, so the RPI configuration seems to be broken and that's why it can't connect. Let's quickly move back here. Oh, we skipped a little bit of stuff here. We jumped directly to the configure. It's a bit annoying that they now create this column on the side and it's like exactly where the index is. Table of contents is behind the thing. But let's see. I mean, wiring we did for sure. That's what the LDO stuff told us. SPI accelerometer suggests twisted pair ADXL. Many MCUs will work with an ADXL345 and SPI mode. Wiring and configuration vary according to your specific board and available pins. Okay, so the wiring is done for us, right? That's the little like tiny board LDO provided us and the white cable. So that should be all done. So this is exactly like what they show here. This is done for us, I think. So that should be fine. There's like different, there's no different setups. And that's where we started, software installation. Okay, first check and following instructions. Ah, this is what we skipped. We skipped the sentence. Set up the Linux MCU. That's what we were missing. Why use the Raspberry Pi as secondary MCU? Often MCU is dedicated to controlling 3D printers, limited, okay. Install, okay. let's just skip to the install. Let's read the first sentence though, otherwise I missed something important again. If you want to use the host secondary MCU Clipper, process must run before the Clippy process. After installing Clipper, install the script. Run, okay. Let's jump to terminal and run this. Okay, that was very quick. It just created, it copied something, created a symlink. Okay, let's see. What's next? Building the microcontroller code. To compile the Clipper microcontroller code, start by continuing the Linux process. Let's see. Yeah, that's where we were before. Oh, you don't see it. I'll be back in about an hour. Yeah, have fun, Alex. Thanks for dropping by. Let's see. So, in the menu, set microcontroller architecture to Linux process and save and exit. Microcontroller architecture, Linux process. Quit. Save configuration. Yes. Okay. To build, we copy the build code. Let's see if that works. It's doing something. Also, we'll have some technical issue here. For some reason, my iPhone that I use here as this camera doesn't charge, which is unfortunate. Let's see if it... Now it charges. Okay. We have to keep an eye on that because it only has 20% battery left. That would be a bad day. So, if Clippy log reports permission denied error when attempting to connect to TMC Clipper host MCU, then you need to add user to the TTY group. Let's just do that right away and just assume that doesn't hurt anything. Okay, done. So we have that in the TTY group. Remaining configuration. Complete installation by configuring Clipper secondary MCU following instruction by, yeah, let's see. But I'm pretty sure that this one is now exactly that's what we have. That's what we have. Okay, then let's see what happens if we now do restart. Does it now come online? No, but we get an error. Cannot update MCU config as it's shut down once the underlying issue is corrected. Let's say firmware restart. I don't quite understand the issue. The difference between restart and firmware restart. MCU Raspberry Pi error during config, unable to open SPI device. Okay, I mean, it's changing. It's great. Let's see. Let's see. I think I've seen that. I think we need to enable in the interface options SPI. Would you like the SPI interface to be enabled? Yes. Okay. I have a sick tech. Yeah, to catch up by watching 2 times speed. I hope you still understood everything. But not much happening so far. Like, I'm still trying to make this work with our new config here. Yeah, where it is. Here's. Let's see. Like, I hope this wouldn't be too complicated. Oh, it's up. Yay. Nice. Okay, so then I guess we can... Oh, you don't see it, but I have like 20 different tabs open with like Clipper documentation. But this one is the correct one. So we have the MCU Raspberry Pi, which now works. Like this configuration we now applied. Which means we can go down to checking the setup. I think restart might restart the Clipper service, which like firmware reset the control board MCU. Oh yeah, that would make sense. That would make sense. Like that firmware restart is like the MCU level basically. It's just a bit confusing. Like it's not really explained in that prompt. What does what? For non-bed slingers, one accelerometer in octoprint / mainsail in this case, enter accelerometer query. Let's do that. Oh, cool. Like it poops out some measurements. I don't think we have to understand the numbers, but it's doing something, so that's great. Cool. So then basically you should see the current measurements. Yeah, exactly. That's exactly what we see, right? X, Y, Z, and then numbers. If you get an error, nope, we don't. If you're using, nope, we are also not doing that. Next, try running measure axis noise. Okay, let's try measure axis noise. Axis noise for XY axis. I mean, that's also doing something. Numbers for the noise of the should be somewhere in the range of 1 to 100. Let's see, what do we have? We have 20, 24, and 29. So it's like in range, I guess. That looks good. Too high axis noise, e.g. 1000 and more, can be indicative of a sensor issue. Okay. But I guess like we see the sensor, we can read the sensor, and the noise of the sensor is fine. So then I guess we can just run test resonances axis X. Let's just do that. Must home first. Okay, that's all. With my freshly fixed up bed. Ballistic tech. I mean, oh, you watched it most likely, but I showed the POM nut. I don't know where I put it now, but it's completely chewed out. Okay, we are home. Let me try that again. Oh, actually, I totally forgot. I saw it like the other day. Let me quickly change it. At some point, I enabled stealth drop for X. Set to 9, yeah, I added set back to 0. Let's set it to 1. So stealth drop basically is a different way of driving the motors. It's much more silent, but it has less power. And now that I want to kind of like ramp up the speed a bit, I want more power for sure. If you set it to 0, the motors are super noisy when the printer isn't moving. If you set to 1, the motors use stealth job if the motor is not using. That's one thing I know. I thought hopefully the new ones last longer. Yeah, I hope so. Like, I have now 4. I actually can show in a second what I did there. Let me quickly finish up this. So this one also goes to 1. And then we can save and restart. What I did now... I don't think I can get it that low. Wait, I have to. What I did now... I'm not sure if you can see that. I can't. Wait. So I added those nuts there. Here I added nuts below the, like this is the MCU nut. It's between them, and then I added the nut here with thread locker. But this is now completely loose. Like you can see, I can completely wiggle it. So the POM nut, my idea was here, the POM nut can just like align in whatever like way it needs to, so it doesn't rub. Like I didn't tighten that before either, like super tight, but now it's like it's just loose. Like the POM nut is like completely, like you can move it left, right, back, forth, like it's completely freely moving. I hope this fixed it. And also I did like 2 prints since. And there's no discoloration on the lead screw. Before, after like 1-2 prints, I saw like gray discoloration, which was like dust from the POM nut being grinded, already on the lead screw. So the problem was like quite early visible. So I mean, it could have been in the end that I just like misaligned the POM nut, or like the lead screw was misaligned. Not sure. But yeah, let's hope this one is better. In the end, like it's a $2 part, so it's not the end of the world. But yeah, like ideally, getting the lead screw out or the motor out is a bit of a painful process. So I'm not looking forward to doing this like more often. Oh, now we didn't home it. Quickly rehome and then let's run that. Let's see. I still didn't figure this one out. Like why after the restart sometimes you have 2 green LEDs. I don't know why. Doesn't sound different. Okay. Here it goes. You can barely, I don't think you can see it, but it's moving ever so slightly. Now you can't see it anymore. Like also can't see it anymore, like, but you can hear it. It's doing something. Yeah, it's like the frequency is like ramping up. There's this YouTuber, like while we were waiting. Not sure if anyone knows that guy. Like, I think it's quite a big channel. Oh no, it's not that big. 690,000 subscribers. So nothing is happening there. So let me. This is so cool. So what he's doing is like he uses like random electric devices to play music on them by like using the motors to like create frequencies. It's very interesting. Should it be in the middle of the bed? Yes. So I think what's happening here is in our configuration that I copied over, it says, where is it now? Pro points 10, 10, 20. I think this is X, Y, Z. That's my understanding, because it's at 10, 10 and it's roughly 20 up. So I think this is just a point that was specified here. But it's a good one. Like, I mean, like it said in the Clipper documentation, you can have multiple ones, but you should do it in the center first. Let's quickly let that finish. But then I think, yeah, I didn't pay attention to that one. Thanks, Ballistic Tech. That was a good one. Let's redo that in the center. Oh, that's done, I think. The noise is gone. Wait, let me change it right away to 60, 60, 20. So that should be the middle of the bed. Save and close. Resonance data written. Yeah, so this one is done. It worked. Let's quickly redo that in the center of the bed. Save and restart. Yeah, you also see the output here. Testing frequency. All the frequencies. Cool. Let's quickly home again. And then let's do this again in the center of the bed. And then I think we need to do X and Y, and then we can look at the data. Okay, let's just do the exact same command again. Yeah, now you see it. Like the movement gets less and less, and like the sound goes up in pitch. Oh, and you see the bone tube in the back is vibrating. Yeah, it's getting really loud towards the end. Like most people don't hear it because of the microphone filters. But there's like one, like now it's getting more like the volume goes up. Like the pitch goes up constantly, but then I think there's like a volume spike, which most likely would even be the resonance frequency, I guess, right? And then like goes down again. Like you can hear like a screw rattle or something a little bit. It's quite interesting. Let's see. Guess it's done in a second. What does it say here? 40? Yeah, it's almost done. I think it goes to like 120 or something. 17, 18, 19, 20. It goes more. $133 is where it stopped last time. 30, 31, 32. 33, and it's done. Okay, so it goes from 0 or from 1, from 5 to 133. I'm not sure if you can configure that. Let's do Y. Yeah, now you see it moving back and forth on the side here. Maybe look at the console when you think it's hitting the resonance and guess where you can think the spike will be low. Yeah, let's do that. I mean, I can also quickly turn off the filter. Yes. Okay, so now the filter's gone. Feel that? Okay, it's attached. I hope this is not too loud what I'm doing right now. Giving you the direct. Not sure if you can hear anything. Now it's quite violent. 75. 75. Like you hear a little bit of rattling in something's rattling a bit. definitely hear it. Yeah. I mean, not sure if this is like a nice sound to hear, but that's the sound it makes. Oh no, there's another like something happening. 114. Sounds like a panel. Yeah, now it's gone again. So it's like there are some resonance frequencies. 95, 26, 127, 128. It's interesting. Like now there's like yeah, it's like every 5-6 hertz, like there's some resonance. Okay, let me put the microphone back. Sorry if that was loud for somebody. Oop, okay, and let me put the filter back. Okay, so that was it. That was the entire show. I hope you were not disappointed. Let's quickly check then the next steps. So we did X, we did Y. We skipped the entire attention part, I guess. Not that important, but this will generate two CSV files, X and Y. Yeah, they were like, also I saw them in the terminal logs. These files can be processed with the standalone script on the Raspberry Pi. To do it, run the following command. Okay, we just copy them. And then let's just paste them in the terminal. It's doing something. Ah, here, recommended shaper is MZV at 73.6 hertz. So I think I called out 74, 75, right? So that would have been quite good. And also here 70. I mean, we can just go with those recommendations most likely. MZV at 73 hertz and EI. So I read up about that before. So basically there are different like algorithms. It's ZV, MZV, EI. And they basically simulate, like they are more aggressive. Like some are more aggressive than others. But let's look at those PNG files. So they should be at /temp. Give me a second. I think I can pull them up. One second. I have to copy them quickly, 1 second. PNG. Okay, and now I can open them in Chrome. Here we go. Here. So this one is X. Yeah, and it's like, exactly, like you really see the spike here, right? That's the resonance frequency, which is like 74. It's like, yeah, 70, 74. What did it say for X? For X, it said recommended shaper is MZV at 74 hertz. So it's somewhere here. And then you see the dotted lines are the different input shapers. So basically MZV would be that orange line going down here. I'm not quite sure like what the criteria would be to pick that. But it seems to be like the lowest line at this specific spot here at 74. So maybe it's just like looking for the algorithm that gives the lowest point in the curve at the resonance frequency. So that's X, and then Y. Ah, see here, like I mentioned for Y, there are like multiple like high spots. That's exactly what it shows here, right? Interesting. And the recommendation for Y was EI at 70 hertz. EI is the green line. And it seems like EI stays quite low for both. It's interesting that there are like two resonance frequencies. I always thought there would be only one resonance frequency. Huh, interesting. Cool. Then I guess let's configure that, and then let's redo our little test print I have here. Like, I would just reprint this G-code, and because here you can clearly see the ringing. Let's see if it gets better with that. MZV seemed to handle the second spike well on the X. X only has one spike, or do you mean the do you mean this little spike down here? Y had the two spikes, and there you had MZV in the orange one. But it is up here, the dotted orange line is up there, and then the EI, which is recommended, is down here, like it's somewhere, I mean, somewhere here. I'm not quite sure, but I would just go with the recommendations for now. I guess it would make sense, like if I have too much time at hand at some point, to just try them out and see how they change. Okay, but I think it also told us how to do that here. Yeah, so it's just input shaper section. Let's add it to our printer config. Let's just add it here, and then MZV 73.6, 73.6, MZV, and here we had EI at 70.6. Yeah, that should be all we need. That was easier than I expected. Like the setup was harder, but like running it now, I thought you need to like really like look at the graph and like figure out yourself what you need to do. But it just tells you like, hey, this is a recommendation, which is nice. Then I guess, I mean, let's try to get this up. Yeah, it's one parameter. Did it have recommendations for max acceleration or anything? I didn't see any, but we can try, or we can look to see if it has any. Let's quickly start the print. Just for the record, so what I'm printing now is this test file here, which comes from Clipper. Like, it's linked in the input shaper documentation. And then basically the settings I have are, I can delete that. The settings I have is basically 0% infill, 0 top and bottom layers, and then oh, I actually changed it in the print settings here. I messed with the print settings. So I set the speed to 120 for small and external parameters. And I enabled vase mode, but I don't remember where. Oh, here's spiral vase. So it's just printing it in vase mode. So yeah, that's what I sliced before. So we can just print that again, which is this one here. Oh. So let's print that. And while this is printing, to close the door. We are printing in ABS, by the way. This is Home Futura Titan or R Titan ABS. That's all the black parts on this printer are printed in this ABS. So let's see what this is doing. And while that's printing, let's quickly check again the terminal. Did it say anything here? It just said fitted shaper to avoid too much smoothing Here, it does say that. It says suggested max acceleration smaller or equal 22,600. So we now selected MZV, and for MZV it's at 16,000. I'm not sure if these are fixed values though. I'm not sure if these are fixed values or if, because they look very not calculated, if you know what I mean, like it's like 0, at the end. Like maybe they're rounded or something, but this doesn't look like a calculated value to me. But it says 16,000 for MZV, and then for EI, it's set 9,300 on Y. So it seems like ZV has the lowest like impact in a certain sense, because like it has like 23,000-ish on X and Y. What the X acceleration seems to be much higher than Y, which makes sense because X only moves the printhead, right? And Y moves the printhead and the entire beam. So it makes sense that like Y would be what's the English word for it? Like it's more sluggish. Like it has higher. Yeah, it's more sluggish. There's a nice physical word for that, physics word for that. But yeah, so it makes sense that Y has lower accelerations in general than X. Let's actually check. Like I didn't change the accelerations at all. Like these are still the values from the LDO config. I guess it would be in the stepper config, right? I don't see it. Here it's in the printer config, max acceleration 2000. So let's see if, let's do the following. Let's print this part as is again with the same settings, just the input shaper. Just so we can see whether the ringing is gone. And if that is done, like it shouldn't take long, it's like 10 minutes or something. It's quite quick. And it's now quite slow because it still has to heat up. Like we are at 65 degrees for the bed and the target is 100. So this still needs to heat a bit for like 2, 3, 4 minutes. But then let's print this exactly as it is again. Because like, I mean, the high acceleration is nice, but my focus would be more that the ringing is reduced. Because like the printer is super fast as it is right now. So, I mean, more is nice, but it wouldn't be like my main focus. So let's see if we print it again. I just need to mark that somehow. Let me just make one snip for the first. So one snip is the first one. And then let's change accelerations to the maximum recommended settings for that input shaper. I'm not sure if we then need to rerun it. I don't think so. Like if we change this acceleration, we shouldn't need to rerun the input shaper. But then let's change the maximum values and print it again and see like time-wise what does change. Does it look faster? And how does the result look? I think it would be like a fun little experiment we can do. We are at 78 degrees. Maybe I shouldn't have printed with ABS. I mean, once the bed is warm, like it's really quick, like to like loop over the print. But it takes like a couple minutes to get on up to initial temperature at first. Can I can't drag and drop that to the other side, so you don't see the temperature. I think. Oh, the browser is stuck. Because I see in a preview, you don't see what I see. Oh, sorry, I'm in the wrong browser. I use Chrome for the streaming and I use Edge for my all the other things. And I was like looking at it in Edge and like, this is Chrome. My bad. Yeah, we're at 85 degrees. I was like very confused because I was doing stuff in the browser, but you didn't see it. I hope this was... No, that was the only thing. I only have the main cell open in both. Let's see, 60, 87. We're getting there. We're getting there. Let's remove this little filament blob there. I think what we can do, like, while this is doing stuff, let me just quickly, like, once this is printing, I would just like transition to working in Fusion on our little mod thingy. So this is the rear right foot from the 0.2 R1. So you see here this the filament runout sensor. And now my plan, or like what I want to try to do, I'm not sure if it works. Let's see. But my idea would be to exactly here where I'm circling now, is to add a button there to load and unload filament. Like looking at this, like there's a lot of space here that is not used. Like there's this like screw thread cutout. So we kind of have to work around that. And of course, like here in the corner, the screw is going all the way through. And we have to pay attention to the M2 here. So there's a little bit of stuff going on, but I think we still have enough space to fit a button there. Is that the tall version? Yes, that's the tall version. So we also have to shorten it by 2 millimeters, which will make the entire thing a little bit more densely packed. Let's see. So I think originally it's printed in this orientation. So this would be facing the build plate. But what I was thinking is like the button should be on the bottom. So it's easier to have a cutout here for the button. But maybe it's then better to print it this orientation. So all the holes are on this side and we can have the button on this surface here. And then we can basically like make this section here hollow. And then you can fit the button from the side, something like that. Like, I don't know if it works. I don't know if it works, but it's my plan. Let's see. So it's doing the skirt now. Let's see. I can give you a little bit like better angle. It's doing the skirt now. By the way, also the Nevermore is now running, and it's really silent actually. I'm quite surprised. I'm really surprised because like 2 of the blower fans, and I always thought like those blower fans are super loud, but it's really decent. Like I mean it's adding to the overall volume of the printer or noise, but it's not really that bad. See, the skirt is slow and then should like speed up when it starts doing the actual printed part. So that's now the actual part, first layer. And that's now layer 2. It's quite fast already. And it's like with the 2000 millimeters per second squared acceleration, which is like standard of the LDO kit. Let's see. Okay, then I would say like let's just let the printer do its thing. This will take like 7 minutes. And then like in the meantime, let's see whether we can make it work. Like ballistic tech, you already pointed out, so we have 2 millimeters less here to work with. Maybe that would be like a first good thing to just like cut out 2 millimeters, that we see the actual height. Now the question is, where did they add those 2 millimeters? I think most likely it's in the bottom section here. That would be my guess. Let's just let's see. So let's just start by capturing the design history. And then let's just make an offset plane on the bottom and just cut out like random 2 millimeters in the middle. And this goes 2 millimeters down. So basically between those two planes we cut out. So let's just split the body. So we select the body and we select both planes. And now you can see there's like cuts along the body. And we have now 3 bodies. And now I will just delete the center one. Delete. And we can hide the 2 planes. Oh wait, what did I now delete? Oh, if I delete it, it's doing weird stuff. Okay, let's not delete it. But then maybe it's smarter to align the plane a little bit. So this plane, let's just align it. Maybe if we just cut it just below here. And then we can move this part up by 2 millimeters. And now we have a shortened foot. So that should be the correction we need to do for our like weird 0.2 or 0.5 or something like that. Now I should remember how to search for commands, because we need to combine the 2 bodies. I know there's a command for that. Split, 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 combine. Yeah, here. So we combine those 2 back together, so we have one body. Okay, perfect. So let's just create a group for that. S is search. Yeah, thank you. S is search. I was like A, D? No. A is appearance. Okay, so let's see. Let's start by just making like a section analysis so we can kind of like see what space we have available. So we have to kind of work around this. Yeah, and those are also quite deep here. Oof. It's less space in there than I expected, or like I thought it would be. That basically means that this phase is completely out of the question already. I mean, you could kind of squeeze it in there, right? Like if you stay a little bit above that. But then it kind of collides in the back. So my idea was to just like create like to cut into the part and have like a little thing that like slides in and out on which the button sits. But to do that, like it would need to be in this section here. In this section here, but that this completely collides then with the holes here for the accent parts. So I think this face is completely out. So if we do the button, it needs to be on this side. That would be my takeaway from that. I mean, what we can do. Oh, what happened? We can just create this like cutout, I guess. Do you have smaller buttons like through whole tactile push button? Yeah, so I have a couple of options available. Let me quickly So my idea, or like my preference would be to use this one. That is the end stop switch, which is the same that the filament sensor is using. Benefit would be, right, like everyone has it because it comes with the kits. But it's a bit on the bigger side. This one was like also one thing was way, like this, the larger version. It's way too big, like this doesn't fit at all. But I also have those, like those little like tiny push buttons. The thing is just like, I don't think like you gain a lot. Like from a height, like from the thickness, basically they're the same. You would save a little bit in depth. But I guess you can like bend those over quite a bit. Let's see. Let me quickly do this like cutout and see how much space we have. So if we say, let's just project a couple of things. Let's project this hole here. Okay, so if we look at that, we need to go quite close, right? So my idea is like to have like from the outside like a button where like you have it attached on the bottom and then you have like a cutout in a U shape or something, or a hexagon shape that you can push it in. So we need to be quite close to that outer side, I guess. So this would be like, I guess 3 layers, so 1.2. Something like that. And then from the hole, let's stay a little bit further away, maybe like 2 millimeters. It looks like too much. Let's do also 1.2. And then from the bottom, I guess technically we can also just do 1.2. Yeah, let's just 1.2 it, I guess. And like, then I would just like extrude that in. You just need to see what the offset is we need, but I guess like something like 6-7 millimeters. Yep, -6. So we stay clear of those 2 holes here in the front. Let's quickly do the section analysis and then let's check the print. Yeah, see, that works. Like, oh no, there's another hole. There's another hole. There's another hole. So I guess it needs to be. So I guess we have like 15 millimeters in depth. So this stays clear of all holes. That's the space we have, which is not a lot. Like I thought we would have more space. And there's also the skirt in front of it, right? So we need to see how to route the cables. But technically we can like extend the cutout to the back and route the cables out this side basically here. And then the skirt comes down and covers this like cutout. Something like that. Let's see. Okay, let's check the print. Very quickly a lot. Hot, 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 hot. It definitely looks better. Like there's no ringing. Like if I put this next to it, and then you still see it a bit. Like if you look here behind the gap, like this like cut-in, you see there's like the shape is ringing behind. And here it's definitely less. Like there's still a little bit of like uneven surface here, I would say. Let me quickly move the camera a bit. So we need to look on this side. There's definitely almost no ringing, I would say. This looks quite good. And then if I put this on top, you see here there's the ringing repeated. So that's definitely improvement. So there was X. Let's check Y. Y was even worse. Like you see, like multiple shadows. It looks like 4 or 5. Like it's basically up to here. There's the shadows. And I mean, there's still a little bit like a wavy surface for sure. Now that's a good angle where you can see it. It's a clear improvement. It's a clear improvement. Cool. So this is part 1. I made one cut here. Let me do 2 cuts. That's the second part. And let me try to carefully lift this very fragile part off. Mm-hmm. Almost in one part. Let's just do this again. Those prime lines are super stuck on here for some reason. Okay, let's do it again. But before we do that, here we go. Let's change the config. So it doesn't allow us to set the acceleration. I mean, it says max Z acceleration, so maybe we can do X and Y like that. And remove this one here. So I'm just peeking at the terminal. So the MZV frequency was max acceleration 16,000. So let's just set X to 16,000 and Y was EI. And EI had 9,300. So let's just punch in the absolute maximum what it recommends. There you can restart. And let's just print that again. Error. Oh no. Max axle in section printer must be specified. Okay, let's quickly see the handbook for that. How does it play together? So maximum acceleration of the tool head relative to the print. Oh, okay, so that's not the individual axis, that's like the absolute acceleration. So we need that to be defined. Then the question is, if I just set, like my goal would be now to have the X and Y acceleration determine the maximum, right? So I would just set it to 20,000, I guess. Not sure if that makes sense, but then I hope I could also just set to 40,000 or something to make sure that like basically one of those two limits it. I'm not sure if that makes sense what I'm thinking right now. Let me just let's put to 20 for now. To save and restart and then like see. Oh, it's still error. Is not valid in a section printer. Let's see, what does it say here? Interesting, because it does define the Z. But maybe Z is different. I don't know. Then I guess let's go with 9300, which is the lower of two numbers. Let's see if we can now do that. I mean, now we didn't add anything, we just changed the number. Yeah, I think now we have a success. Let's see if we print the exact same file again. There should also be history, right? So right now it took 9 minutes 23 seconds. And the one I did just before the stream was 9 minutes 22 seconds. So it's exactly the same print time. Now we changed accelerations, right? So now it's 5 times as high, I guess, like from 2000 to 9600. Let's see if it's quicker. The bat needs to be heated up a little bit more, so let's wait. I'll keep it on camera here. Cool, let's go back to our little fusion experiment here. So then basically, I guess we can just extend this here all the way to the side. Let's just make this like construction line. Okay, it doesn't want to. But then we can extrude those maybe like 10. Oh, minus 10, please. So we can just cut in there. Oh no, there's the hole again. So I guess you have to go maybe to 7. I guess that's the best we can do. Let's see, what clearance do we have here? I mean, now it should be fine, right? Like we have now a little bit of space there. So that's basically now space we have to work. Let's also do the following. Let's quickly import the skirt from the 0.2. So I have two designs here. That's a 0.2 R1, and then this one is a 0.2 original, basically. Oh, Ballistic Tech, I completely missed your comment, sorry. I'm not sure you can split it in Clipper. I think RepRap can. Yeah, like seemingly you can't. So it's a total acceleration only. Let's see. Let's just grab one of those skirts here. So it's skirts, rear skirt. Can I? Yeah, let's just do save copy as. Oh, you don't see it, but saving a copy now of that single thing. Yeah, and now I can go here. I think I have to save that. And then I can insert into current design. Yep. And then maybe it lets me let's align this hole. Oh, it's starting. Oh, it's still doing the skirt. Let's wait for to have the skirt done. Okay, but this is now how it would look. I think I took out the 2 millimeters at the right spot. That would be like how I interpret this here. Looks about right, I guess. It's not perfectly lined, but it's also not perfectly lined on top, so I think that's kind of how it's supposed to be. So, okay. Cool. Then we also now see how that would interact here with the skirt. I mean, let's see. Let's jump to the printer, but then I guess we can just model this little switch and see if it fits in there. See, that's not a first layer. I'm interested to see if there's like a visual difference now between those acceleration values. Oh yeah, I think it definitely is quicker. So 9 minutes, 22 seconds is the time to beat. Let's see, cool. Okay, so I'm not quite sure if there's a part number on that. D2FL. But in the end, we could also just measure it. But let's see if there's like... if we Google that. Oh, that's the wrong one, let's see. So I'm just Googling the number that's on this part. So this is D2F-L microswitch. Yeah, this looks what we need. And now I don't know, like there might be a database or something we can download stuff like that. But on access denied. Oh god, no. Oh, so I'm usually like, you don't see the URL, but I'm very frequently like taking stuff like that from GrabCAD. But this page is currently undergoing maintenance, which is awkward. Yeah, but I don't think they have a 3D model for us. Oh god. I mean, I guess something like this would work. This looks relatively... This looks exactly like what I have in my hand. But this goes to this web page, which is undergoing maintenance. I really wonder if there's like a database, like there must be like online database. Let's see, like this is a bit more basic, but it's STL, which, yeah, not so nice, but then I guess we can insert mesh. Select that. Just moved it here. So that's our micro switch. It's not nice that it's like a mesh, but let's take it for now. Just to see how this kind of would align. So if we move this part, no, it's one of those where it looks like it's where you think it is, but it's definitely not. Okay, so I mean, it fits from that perspective, at least. But now I guess it's also way out. No, it looks better. Okay, so we kind of would need to fix that on something, right? Like my idea was to have it like something slide in. But this is like a very tight fit already. I mean, what we could do is to clamp it into position, basically. So if we align it basically to the top here, something like that. And then the switch part, I mean, we need to have a cutout on the front, but just position something like that. And then we just now create a part that basically slides in here and holds it in place. And then the cables need to be like routed out here. The empty stack file I found. Oh, nice. Let me see. I don't have Discord open though. 1 second. Definitely seems quicker. Let me import that step file. Thank you. The site I found it on unfortunately requires login. Yeah, okay. Yeah, I don't have any accounts for that stuff. I always Google it and like I usually find it. It's processing. Complete. Okay. And let's get rid of that. Insert into current design. Then I guess we have to rotate it this way. And then let's just do point to point. So let's just align this. Oh. It's not quite what I wanted to. Oh, God. Right, let me first bring this somewhere close. I'm struggling hard to align that. Let me just align it with something here first, so we have it in the same. Where's this pivot point now? Okay. Let's check the print first. Still looks really good. Like I don't see any ghosting. This is interesting. Like there's this discoloration. Not sure if you can see it. Yeah. There's like a little bit of discoloration here, which I'm not sure where this is coming from. I mean, now you see a bit of ringing here. If you compared it with the second part, this one is the second one. Yeah, you also had it here. But it's definitely more pronounced now. Like you definitely see one clear ripple where here you did not. Now you see one. Maybe it's not worse. It's a bit. Like I can now see it from my angle. Yeah, here now you see it, right? Yeah, perfect. So the top one has 1, 2, 3 ripples, and the bottom one has like 4. So it's a bit more. I'm still not quite sure where this is coming from though. If it's still like the shadow of the movement or something else. Because it doesn't have the, like it's vertical, right? It's always at the same position. So maybe there's something like in the rail or something that like causes like a little bit of like a bump there. Like it goes towards the entire part. In a very regular interval, right? So maybe there's something in there. Is it like VFA? Might be, but my understanding was that VFA was... Wasn't VFA like in like vertical direction basically? That might be. Might be. I mean, this looks a little bit... It looks different than what I see here. But this definitely looks like what I have. Yeah, it seems like a complete debate here, so... I mean, it might be that it's VFA. I mean, this looks extreme. But basically is what I have, right? Like this like perfectly vertical... Yeah, okay, that seems like something I want to try. But it also doesn't bother me too much, to be honest. Like you only see it when you like hold it into like the light in a specific angle. But now the important part, was it quicker? What did this do the stats say? 10 seconds. 10 seconds quicker. Like it was like 9:22, 9:23, and now it's 9:10. So teeny tiny tad quicker. Now I guess I would just keep those values for now because it looks good. I'm still a bit confused about this like it's like, I'm not even sure if it shows... Yeah, you kind of see it, right? Like the color here on the bottom is like more gray and then it's like a darker black. And it's basically like this like spot here where like the color is different. Oh, it's also here. Yeah, here you see it, right? I wonder where this is coming from. Maybe it's like some temperature change or something that like the temperature changes a bit. Can increasing stepper current help with artifacts? I'm not sure, but from my... I had a quick discussion with, can't remember, in the LDO channel regarding the my palm nut issue, and I was told that increasing the stepper can cause wear and other issues, so I wouldn't increase the step current. I know that, like, I mean, Prusa had the VFA issues fixed with their Mark IV, right? And they used 0.9 degree steppers to do so. So maybe it's just like inherent flaw of 1.8 degree steppers. But I didn't look into that enough to, like, I don't have any advanced knowledge there. Well, I don't know if there's a fix. But to be honest, like now the ghosting is completely gone. So this is like the second part. Ghosting is completely gone compared to the first part. And that was like what kind of bothered me a lot. Yeah, this one is the first one. You see like there's tons and tons of ghosting. And now it's gone. Like there's one little ripple, but way, way, way better. I mean, that's not most likely where I can like try out different like smoothing algorithms. But then like if they get too aggressive, like you most likely will get issues with like sharp corners. So I'd call it a win. That's definitely already like a good improvement. Yeah. So I guess input shaper is checked. That was the last kind of thing I needed to do for the build. Let's see if we can get our little mod off the ground. I moved it now into the part. So let's get it out. So I guess we can just align it to the top here. Oh, but I wanted. Oh. Wait. This top edge goes to that top edge. Thank you. And we need to remove that clip most likely. Like that needs to go. Yeah, then I guess we can align this edge. Oh. Well, now it's gone. Move, align. Let's just align maybe that here. Okay, thank you. And then I guess we should move it like a little bit back so that the switch part is not in the maybe 0.8. And let's also move it down a little bit. Same distance. Okay, so then let's see, can we hide this? No, that's the entire part. Can we? No, it's one body. Okay, well. I guess we have to live with this like random thing there. I mean, it gives us enough space for the cables. Like most likely we have to solder the cable because there might not be enough space. What we can do actually, we can add around like a radius here to give us a bit more space because the hole is round as well, so that's helps a bit maybe. And then let's just create a new component. Let's call it just slider. And then let's create, yeah, capture position. And then I guess we can just project this entire area here. And yeah, let's just extrude that. I guess we can just extrude up to that sensor. And then the question is, how do we fix the sensor in place? Let's just add a little bit of like let's just push it in a bit so we have a little bit of like tolerance. Let's do 0. I don't know what tolerance Voron works with, but let's just work with 0.15. So now there's a little bit of gap. Now, how do we now fix this in place? I mean, it's constrained from vertically. It's constrained. You could screw through the sensor into the bottom plate and then maybe cut a slot out of the foot for the screw heads. The other problem is like there's not a lot of space. I mean, I could technically you could screw, like my idea was like to have this like thing sliding in and out. But technically you could screw through the entire foot. It's just a little bit awkwardly aligned now with this button type. Because like the hole is, it's kind of like on the edge here, right? Wait, I have to. So that would be somewhat here. Yeah, it's just on the edge of where this like bottom part comes in. So it's like kind of bad spot to screw through. And like here it's just not like deep enough to screw anything. I mean, vertically it's kind of like squeezed in. And there's like a bit of like space above, which we can maybe fill in with like 2 layers. I mean, we can just technically, not sure how well that will work out. But I mean, we can just fill up the space in the back. So we just project this area here. Let's just it's just wait, that's what I want. So we just extrude this here. I mean, what they also do in the Voron team is like they create like little printed notches here. So I mean, technically we now have that like marked, so we can just extrude. Oh, why is this one? This one is different than that one. Is it in reality like that? Oh god, it is like that. Interesting. Like one of them is ever so slightly oval. But let's just extrude like 2 millimeters or something. And then let's just fillet that. So we have like 2 little bulges basically. That would kind of like horizontally constrain it. And if we then I mean, at the moment, we didn't move it all the way up, right? We didn't move it all the way up. So if we now basically like thicken that section on the bottom a bit, like it would also be vertically constrained. Do you need some clearance so they fit inside? Yeah, I didn't add clearance yet. I didn't, we can do that. Let's just add, I would just have done that. So 0.15 is what we did, right? No, that doesn't work. Can I do it like this? Yeah, that works. So we do it there as well. Does it work? Seems like it. But I think I need to select those sides as well. But now it's like 0.3 in total, right? Because I do it on both sides. So let's just do that. Divided by 2. And now if we check from top, there should be tiny bit of gap around, so that should be fine. Like, it will be like a real tight fit, but it kind of has to, I guess. Let's see, we also have, this is such a messy file already. So if we edit the capture here, and just moved it up. We moved it down 0.8, so if we just move it up 0.65, we have the same clearance here on top. So if we update that and finish, yeah, exactly, now the extrusion updated. I mean, this will be tight, but it's kind of like the idea, right? That it's like a really snug fit now, because like we don't screw it down, but now it should be constrained vertically and horizontally. And then basically what we do, like, let's ignore this like metal part sticking out here. I hate it, like it's always like zooming somewhere I don't want it to go. So if we now just create, where is it? Where can I make a hex? Polygon, center point, but can I specify the number of points in a polygon? Oh, I can. Okay, let's just create a random hex, because like we need hexes. And then let's make that straight. Where do we need that? Can I move that? Yeah, I can move that. Let's also just give it a size. Not an angle. Okay, let's just do this one. Oh, come on. Let's just say this is 7 for now. And then I guess it would be nice to kind of have it centered visually here, right? Question is now whether that works with our switch. Can you hide the lever in the switch component? No, it's one body. That's the problem. Like it's one or nothing. It's like there's just one body. I already checked. I mean, I could. I mean, it's already messy. What I could do is I could finish sketch. I can create an offset. I need to break link. And then I can go in here. And then maybe I can just make an offset, not there. Offset plane just in front of the switch part. 0.8, 6, 5, 0.5. Then I can just split this body with that plane. It's not really nice, but now it's gone. It's most likely quite close to reality. Oh, it's still there? Oh, because the sketch is done. Now it's gone. Okay. So I would just visually center that, and then we need to see, maybe we can like flip the switch around if it doesn't match the position. Let's just create a line to that edge. Oops. And we create a line from here to there. Your construction line and your construction line, and you are equal to this one. And then technically if we give this like a vertical position, let's say 2 for now, then I wonder why this isn't. Huh. I would have expected it to be now like fully constrained. Not sure. Okay, let's see. So if we have that here, I'm just cutting it out for now. So we see where we are. Oh, I now cut also the switch. Wait, that's not what we want. Only want to cut it. Yeah, so basically now if we do that, I'm not sure if that would be like a nice click. Like we can move it up a bit. So if we do like 4 here. But it means basically we need to like move that switch all the way to the back, right? And then technically we can like move that up a bit more. And now if we would move the switch to the back, like it would be kind of in the right spot. So this needs to go. Can we do -2? Section. Yeah, now it's all the way on the back. That's actually like hilariously well aligned now. So let's just finish that. Now that all updated. It's such a coincidence now that it fits like almost perfectly. Yeah, now like this like switch part would be in a really good spot, right? Like if you click that, like press that button. So if we now, let's do -0.8. Let's just connect those two here. And now technically we can cancel. Yeah, we can update that to not include the center part and the top part. And now you should be able to press that, right? That was my idea at least. It's just a question, like the top part of the switch doesn't have any give to it. Yeah, Alex, what about the LD? Yeah, I don't think we have space for LED. That was my plan, but let's see, like if that would work like that, I would already be happy, but like right now you can't press the switch yet. And I'm also not sure how that would print, to be honest. I'm not sure how this should print. Because like, you would need to print it with the blue face on the print bed, right? Like it's the only way you can print it with that button cutout. But then if we do that, I mean, like, then basically the section we have here, like, right? Then that would all be fine, like that would all work, that's all working. But then basically now we hit this overhang here, which is like a 90-degree overhang. So you would need supports for this section here. So we need to figure something out, because you can't have it like as a 45-degree here, because then you basically don't have enough space for the button. Oh, but it should work, right? Because it's like on both sides. Yeah, it should work. No, it should work. Like it's on both sides, so it's just like bridging it. That should work, of course. So we just need to figure out how to make this button clickable. Because right now, like this section here doesn't have any way to like let the button travel back. But I guess what we can do is we can just make an extrusion of this. And then we just extrude from object, and then we select this inner wall here, and then we say distance, I don't know, 1, -1. So we just create a cutout basically inside. And then if we do selection from here, it's not looking how I expected it to look. Oh, because the extruder was missing. So this like area here is now completely like free, right? So you should be able to like press this section here in. Oh, but I cut the button again. I keep cutting the button. This one, objects to cut, foot. Yeah, exactly. So this, I wonder whether this will print. How about we just kick it into the slicer? Alex, what surface is it printed on normally? So normally it's printed on this side here. But that doesn't work. Like we can't use it because of the screw holes here. Like they take up all the space internally. So we need to use this, like the back side basically. So this is the skirt that goes onto there. And then basically we would have to print it on this face instead. But it should not matter because like the I thought that's a 40. Oh, that's not a 45-degree angle though. Let's see. Let's just throw this body into a slicer and see what magic happens. Switch to Prusa slicer. Let's ignore that. And then basically we would need to print on this surface here, right? Yeah, it's just let me quickly reset all the changes I made here for the test. What did I modify here? Cool. Okay. So if we slice that, how would it look? So exactly, we have that like on the bottom layer, we have our like cutout here. Like maybe we can make it a little bit thinner, like the gap. This layer looks good. Yeah, this layer is problematic here, right? Oh, wait, wait, I was like... So this layer is problematic. I mean, like the problem here is that the cut we have, like with this like gap, is like too deep. This shouldn't be here anymore. But then the rest of the part is the same as before. Okay, let's quickly check what happens to that cut in there. That's a really messy file. So this one is way too deep. Oh yeah, we just cut it to 3. So we should, let me hide that skirt. So we just should do it to object and just cut here that deep. Let's save that out again. No, I don't know which one it was. Let me quickly save it again. Here we go. And then this needs to go this way. Slice. Yeah, here it's a problem. Like this. Yeah, the cut needs to continue there. Ah. I mean, technically what we could do as well is have this include this all, and then maybe we can just cut it out to the back wall, which is like a little bit unnecessary. But if we do it like that, let's quickly see, do we have any... Like if we now just cut it out like all the way back. I mean, now our button isn't like vertically restrained anymore, which sucks. And we cut some random hole here, so that doesn't work either. No, it doesn't work. But what happens if we just cut it? Let's just say we cut it -4 or something. And then add a chamfer here to like round or like fill that out. Is there an edge I can chamfer? I mean, now we would have like this chamfer, like not saying it's perfect, but like that way it's a little bit supported. Hi, Ironic. Let's save that out to Prusa Slicer. Oh god, you were looking at the slicer the entire time. I'm so sorry. I am so sorry. Oh, and now something happens. 1 second. Now my everything is messed up. Okay. Nope, now I'm back. So the one that's facing in the right way is the old one. So let's paste it up. This way down. And then let's slice. Let's see. So yeah, see, now we have this lip I added. Like here I added this weird chamfer. I mean, this will still droop a bit, but it doesn't matter if it droops because there's enough space. And it doesn't interfere with the screw hole. So this would like solve all the slicing issues if we do it like that. Then the question would be, is our button still like secured? And I think the answer is yes. Like this is like still vertically restrained. And you see here, like this is like the chamfer I added. So the button would still be vertically restrained. And you see here, that's where it makes contact. So if you press it, like this should trigger. I mean, maybe we find space for LD as well. But I think it's really, like, this is way tighter than I expected it to be. Like, before Ballistic Tech reminded me, I completely forgot that I have to, like, take off, like, 2 millimeters of height. How about that? How about we just do a test print of that and see how it works out. But we don't have to print the full thing. Like we can split this object, right? 90. Oh, I can't rotate the view. Oh, I can. Where's the interesting part? The interesting part is basically here, right? Something like this. For some reason, like, it's super laggy right now. Yeah, this is the interesting part. So if we cut it like that, and then we can print this little, like, sliver here. How long does it take to print? 35 minutes. How about we change the infill to like 10%? 31 minutes. But it would give us like the, I mean, the important part would basically be the bottom section, right? Like, does this correctly print in some way, shape or form? I mean, we can also like cut it vertically here, right? Like we don't need to have the full height. Prusa Slicer is lagging right now, really bad. Don't know what it is. It's just... I guess this should be a little bit higher. I kind of want to have this as well. Foam cut. And then this part we don't need. No wait, that's the part we need. This one we don't need. And then this one needs to go on this face again. Slice. 19 minutes. Now we're talking. So this should give us the parts we need. Then let's also export. Let me quickly export the other part. That holds the button. And then this needs to go. Oh, it's really not fun right now. Like I can barely turn that. And I can't like auto place the parts for some reason. Okay, 22 minutes for those two parts. And then we can see if it works. Let me also quickly do filament settings. Let's do the bed to 60 degrees so we don't have to wait that long to heat it up. Upload and print. Here we go. Would be fun if I had now like a second Voron printer, then we can like try out the button already, but I think we can do a little bit of research how to connect that button. I mean, in the end, it's just a G-code button and we can just like connect it to the MCU. And when the button is pressed, we should be able to like trigger some G-code. And then my idea is like to check the filament sensor. If the filament sensor is loaded, we call the unload filament macro. And if the filament sensor is empty, we call the load filament sensor macro. And then maybe we can also add like a little icon on the button. Let's see. I'm curious to see if that prints and if it works out. And if it fits. I kind of have my doubts. We need to work a bit on tolerances maybe. Cool. Yeah, let's check some Clipper macro stuff while this is printing for 20 minutes. Let's see. So yes, we can close all the input shaper stuff. And then would be Clipper G-code macro button. Feature request that doesn't look good. Just quickly check if that is doing the first layer is acceptable. Like there's some blob. But that's only in the outline. Oh, we wanted to reduce the gap between the two sections. Oh. Cable is a bit too short. Here we go. Oh, okay, I have to, that's, for after stream I have to like move the cable a bit. Okay, now it's enough. So the gap between the button is quite, like the pressable part of the button is like quite large. We can definitely tune that a bit more to be a little bit slimmer. You can look up the orbiter filament sensor config, see how it works. Oh, true, the orbiter has that. Clipper or bitter extruder? It's interesting. It sounds differently. Like before, when it did the solid infill, like you could hear it accelerate and decelerate. Like there was like a yeah, you could hear it like speeding up. And now it's way faster on that speed. Like the acceleration time is way quicker, which we configured. So hey, no surprise there. But it's interesting that you can really like hear it. Man, it's such a fast printer. Love it. Love it. Well, this is problems, but let's not go for problems. Yeah, but it's just the extruder itself. Because we want to have the button config. That's also not quite what we want. That's extruder, filament diameter, sensor type. No. Interesting. Ballistic Tech, you have it on your 0.2, right? Does the button work for you? Or didn't you configure the button? Because it has the button here on top, and that's exactly what we want. Configuration for Clipper. G-code button. Okay, so we need to check for Clipper config G-code button. G-code button, here we go. Execute G-code when a button is pressed or released, or when a pin changes state. Yeah, so basically we can connect it to like some pin on the SKR, I guess. I technically we could also now do it on the Pi directly, because we now have the Pi configured as MCU. There's a link to CFG on that page. Yeah, but I guess the G-code button is already what we needed. Here's the CFG. Let me open that directly here in the browser. Ah, cool. Yeah, but they already have the script here. Perfect. They show how to check temps and auto heat it up and such. Yeah, exactly. Like I do have a filament unload, a filament load macro already. But I think the interesting part is here, for example, this if printing. But it says sensor release. I don't think it's the button. Printing. That's delayed. Change state. Man, it's complicated. Yeah, it's a filament load macro, filament unload. I have those. Sensor SU is unload button. SU. I don't see SU. So G-code button, we have FS and FU. Yeah, I guess that's the button. So they just check if it's printing, which is a good check. Like I would have thought of that, and then I would have ruined the print at some point. Filament unload. So they just call it. Yeah. Foo's unload button. Filament unload, I guess. So it looks quite simple. I mean, for me, like what I want to do is I want to query the filament sensor, but I know there's you can query the filament sensor clipper, filament sensor query, because then you can check whether the filament is in or not. And if it's in, you can unload, and if it's not, then you can load. Oh, I saw it in a preview. Query filament sensor. Yeah, the operator, they just make the sensor a G-code button instead of the define sensor. Yeah, exactly. I mean, it works, I guess. It just shows up differently in the UI then. Because like for me, I now have it down here as runout sensor and says detected. But now the question is if I do this, like, I mean the sensor, filament, sensor 1, so it's runout sensor, I guess. So if I query that, it should give me something. And then we can just have an if with that, right? Filament detected. I mean, I'm not quite sure what in script it would give me. If it's filament detected, like, I mean, what they do here is they have this if, right? But they say printer print state state. State. Where does it say here? Configuration reference, bed leveling, resonance, clipper printer dot state. Status reference here. Filament switch sensor. The following information is available: filament switch sensor, some name objects. Enable filament detected. Returns true. Print is having problems? Print is having problems. Thank you. Well, that sucks. I don't have exclude object. I guess. Let's do that again. So I guess 60 degrees on the bed is not enough with ABS. Let's heat it up to 100. I wanted to save time, but no. It's also tad high. Like, it's not super high, but it's a tad high. But I mean, we can already see the bridging worked. Like, it printed this part kind of fine, and you can also see the button, like I can press the button. So if the bed is already heating to 100, by the way. So this shouldn't be here. So this might be an issue. But I mean, the button would be something like here, right? So this would then be like that. We need to remove that. So let's do it right away. And it's gone. So this would be like here. The question is now, did we leave enough space there? But I don't think it's triggering. Let's see, but it would be like here. Yeah, like that would work. Like I hear it clicking. Okay, let's see. Let me move it down a bit. Like I'm still like with my Z offset. It's still a bit weird. Let's put that back. And then let's just reslice that quickly with the change I did on the filament config removed. Okay. Thanks, Ballistic Tech. I did not pay attention. I did not pay attention to that. Okay, so status reference. Back to the fun stuff. So we have the status filament motion, filament switch sensor, which then should give us filament detector. I'm just not sure what the syntax for that would be. Is it part like we saw printer? Does it say printer here somewhere? Or is it all on a printer? The document is a reference of printer status information. So if we check here, oh, where did we see it now? Oh no, here. So they say if printer.print states print stats state. So let's see where print stats is. Okay, so this is on the same level here. So I guess we would then have if printer.filament sensor, filament switch sensor, but then I'm not certain the sum name. How do I use that? Is it then .my sensor? I guess it would be .my sensor. That would make the most sense. I'm not sure. I guess that's something we need to try out once the print is done. So basically we would hook up the switch to some port. And then we need this G-code button script that they have here. I mean, for today... Oh wait, there's a bit of filament on the nozzle. I can't grab it. Well, okay. Now it's too late. Too bad. Let's see if we will have like a random bit of filament hanging out. Let's see. So how long will this take? How long will this take? 20 minutes, okay. Let's see. So I kind of want to see if it prints. Or like if it fits, that would be like my goal. And then I guess that would kind of be like the proof of concept would be working. Let's see. But I think like, I mean, it fits in cat, so I guess then it's just like, oh yeah. Look at this warping going on here. No wonder that failed. I mean, it works in cats, so I'm pretty sure it should also work in reality if we get it printed. Like, I'm still a little bit skeptical with this one corner. But then I guess it's like a cool mod. Like, I need to clean up the file and everything and make it work, of course. But then I can just press the button and like the filament's unloaded. That would be really cool. Only downside is now we don't have a LED. But looking at Fusion, like I don't see where we can squeeze a LED in there. Oh, now I know why everything is so sluggish. I'm out of memory. Cool. Let me quickly save Fusion. That explains a lot. Let me quickly quit Fusion so I get a little bit of memory back. Like, what mistake I made when buying this laptop, I went for 16 gigabytes of memory. And that's haunting me. If I have too many things open, then yeah, it's slowly dying. And Fusion is no help for that. Yay, everything's faster again. Cool. No, yeah, but I don't see where we would fit the LED there. It's a bit of a shame. Like, technically you can use the LED here to indicate the status. And there is this Clipper plugin I saw in the Poke Steve channel, where you can configure like LED effects. So that would be cool to have like, you know, like a pulsing LED while the filament is being unloaded or something like that. Need to see what's possible there. Yeah, I think now I don't see warping. So sticking to the established filament profiles seems to be worth it. Let's see. What happens if we say speed 120%? Can we do that? Seems like it's doing it. You can possibly set a global variable when the filament sensor changes states, then check the variable in other macros. I mean, that's also possible. Because you have the delayed G-code thingy, right? I saw in the Clipper config. But I think it should like, looking at this if statement here, like we know from the configuration, from the reference here, that the filament switch sensor is a field in there. So it should be, oh wait, where is it now? So it should be like printer.filament switch sensor.filament sensor name, and then .filament detected. And it should be true or false. And then based on that, same what they do here with printing, like I would keep the printing, right? I mean, maybe we can like piece that together, like while we're waiting. Let's just create a new file. Filament runout.conf. And let's just copy this entire like button for now. And Then basically we can also, let's save and close it, we can also copy over the printer. Or I haven't seen any macros grabbing it out of the printer object, but that doesn't mean it's not possible. I mean, that's what they're doing now here for the config, right? Like here they directly say if printer prints that state. And I think I've seen it before somewhere. So I would just like go with that for now. Let's just grab this one. And we just define it here, runout sensor. That's like the oh wait, you don't see what I'm doing. This is the unload button. We need to check the pin, of course. And then this would be printer. So we keep the printing, right? Did I not copy the correct one? No, now I copied the switch. We want this one here, right? That's the one we want. So on the release, we check if it's printing, and if it's printing, we don't do. We just keep that. But then in here, we do another if and another else, right? And we do an end if. So that's, we just keep that. And then we would say printer dot filament switch sensor dot runout sensor dot filament detected equals, and then I'm not quite sure how this works with macros, but I guess like this, equals true. Do I need that? Maybe we can also just do it like that. I'm not sure. I mean, we just have to try it most likely. But in this case, so if filament is detected, then we unload. And else we load. Now I just need to check, because I have in macros load. Yeah, it's unload filament and load filament. So I have those macros and they work for me, so I'll just keep those. So this one is unload and this one is load. Let's just call it unload button. I guess that should be it, right? So if we are printing, if we're not printing, then we check the sensor and then we do unload or load, and else we do whatever. I don't have a display, so that doesn't really matter. But we just don't do that. So if some idiots like me presses the button during a print, nothing happens. And then here we just need to figure out where to put that, which we can also do now while this is still like doing its thing. But now it's looking better. So SKR mini, and not SKR Pico. Pin out. Let's see. So we have plenty of stuff still free. So the E0 stop is of course taken now with the filament runout sensor. But to be honest, we could just use the Z stop here. It's like wrong label, of course. There's a server pin on the bottom right. There's a server pin on the bottom right. Which servo pin do you mean? I would just have put it into the Z stop. So it's IO25, which I'm pretty sure should be free. Oh no, Z is taken. Z is taken. That's the only one that's taken. So I guess we have to go for Y and stop, which is IO3. Z is taken. That's the only one that's actually in use. So then we just go for the Y, I guess. The only answer is like this one is two. Like we have to redo the cable anyways, right? Like way too short. But it's a 2-pin, so we have to like change that. I don't think you can populate X, Y, and stops and still use sensors. Well, just configuration thing, right? Like this is IO3. And as long as we don't use IO3 for anything, like Clipper shouldn't care. So it's GPIO 3. Oh, it's mentioned here as end stop pin. Interesting. Interesting. But it doesn't do anything. Maybe it's internally like when you put the jumper on, that it's then routing that to IO3. So this is actually in use. You might be right there, Ballistic Tech. So that takes out those two. I mean, we could also put it in IO27 then. And we can also use it on the Raspberry, right? Like, plenty of stuff free. Yeah, we can use GPIO27. LDO picobellical overrides the setting. Because we don't use that for sure. So that would work. And the other one's 26. Where the bed is plugged in. This one is populated actually. Oh god. Well. So you meant this servo here, which is this one, I guess. And we could also use the probe as IO29. Oh, it's umbilical GPIO29. Yeah, so you're right, Ballistic Tech. This one would be free. No, it's this one here. Those three, they are free. So that would work. That would work. What also fascinates me right now, like I put it to 120% speed, right? And it's like just doing its thing. Is it at 120? Yeah, it's at 120%. It doesn't really care. It still looks good. What's the estimate here? 6 minutes left. Let's push it a bit. Yeah, then I guess like the servo pin is the best we can do. If you leave the physical end stops connected, sensor solving will not work. Yeah, okay. I'm pretty certain that they just like internally like connect that, because like it's still configured to be. It's still configured to be the IO3. So maybe if you set that Y diag jumper, it just like internally wires that to this like to the same pin basically. So if the motor is skipping, then basically the button is, or like the switch is pressed basically. Flow rate looks quite low most of the time. Yeah, like I mean it peaks. I didn't figure out how to do that. Like the problem is my prime line has like over 50 millimeters cubed per second. And I would love to like reset that stat after the prime line, but I can't, which really sucks. Yeah, I bet that's what the jumper does. Yeah, I'm pretty sure it's just like some connecting magic. But for flow rate, like if somebody knows like how to reset that after the prime line, that would be tremendous, because like I didn't find any history where you can see like, oh yeah, that's the graph, how that looks. That would be really handy. Should be done in 2 minutes, so. But I'm also not certain if it now goes like full speed, because it just goes up to like 50, 60. So there might be something limiting it, like layer time or something. Most likely that's what's happening, because like the layer times are quite low. Let me quickly check that if I have it configured. Oh yeah, here, slow down if layer time is below 10 seconds. Yeah, so that's my fault. So that's why it's quite slow right now. See, 1 minute 50. Looks good. This could be a winner. Then I guess what we can do is, like, while we wait for the last minute, let's rewire that for 3-pin, because that's what we have then there. I'm actually not sure if I have JST here. I might need to grab one. No, I don't have 3-pin JST headers here, connectors. Okay, let me quickly grab my magic box. 1 second. I'll let you watch that. So let's see. Nope. Success. This looks like the final. Oh, we're done. Nice. Let's see what we have here. Woo. Hot. Very hot. Why does that need to be that hot? I mean, I could wait, but not really. Here we go. So let's start with that part. So let me quickly. Let me do it like this. So I'm still trying to understand square corner velocity. I have no clue. I actually asked myself the same question, but couldn't figure it out. So it's in there, but it's a bit wiggly. So maybe the tolerances were a bit too big. Like, I mean, it's fine, right? Like for the first run. And I mean, here the button, you can press it, so that also works. This won't slide in though, because we need to. Yeah, see, like you can see that, but like the wire collides now here, so we definitely need to resolder that to make it go in there. For now, what I would do, it's just, I mean, this cable like is no good anyways. That's not really going anywhere. So let's see if we can just do it like that. And then this goes onto this little slat. Yeah, that could work. And then this goes in like this. Oh my god! Like you can't hear it, but it's clicking. It's clicking, and it's not wiggling around. Like it's like this is a secure friction fit. This works. This definitely works. This is so nice. And then basically like, I mean, the wires need to go out like this way, right? And then here on the side, you will have the skirt closing it up. So it's not like this can't slip out or something. We need an icon though here, right? I'm actually not too, I mean, like we can like reduce the gap here a bit. But there needs to be an icon. So we need to find an icon. Besides that, this is like, I think that's a really cool mod. Like you just click and it's like, I'm not in it. Let's do the following. I mean, I'm not gonna wait for the full part to print. Let's check. I'm not sure if I now broke the cable here, but let's add this here and see if we can see if we trigger something. There are Voron SVGs you can find and pull into Fusion. Yeah, I was thinking about the Voron SVGs. That's one option. What I like to do sometimes is I go to fonts.google.com and they have icons here. And they have a lot of icons. So if we search for arrow or something. Maybe find a nice arrow. That was my... Yeah, but my problem is like it's not eject, right? It's also load. But eject would be a fun thing. So they have it here. Now the cool thing about this here is like you can customize the symbol. So you can fill it. And then you can change the weight of the lines, which, yeah, I mean, here it's mainly scaling it. It's really cool. Like I really like this library. And then you can just download the SVG. I had to close Fusion. Okay. Let's focus on the G-code stuff. And then like after the stream tomorrow, I just finish up the Fusion thingy and then I make put it on printables. But I think it's like, I'm really happy with that. Like I didn't expect this to be so nice and clicky. It's nice. And like those little like knobs are like really doing their job. Nice. Compare. That would also, like I was thinking of like two arrows like going, yeah, this would work. Compare arrows. That would work. I mean, I also was thinking about like reload or something. Refresh. Something like that. But then I'm not, like I'm always like this, the simpler the shape, the better for printing it is usually, right? So I guess the eject, I'm kind of in favor of the eject because it's very, this should be very easy to print. I think I'm sticking eject. You convinced me with eject. Cool. And let's do the following. Let's repin that plug. I just hope that I know. I mean, it's kind of ugly, but you really need to solder them like coming like this direction then. That's the way to do it. Let's just... do that, and then we can revive those again. And then put them in their new home. From 2 to 3. Clear upgrade. Okay, let me quickly make a bit of space here. And not sure if Alex is still watching, but I think I stick with what you did as well, and I just hide that cable somewhere and just keep it here. Then I can just rerun that whenever I need to. I think this is the servo port, this one here. Yeah, so it has IO29 on the side, and now we're going it to ground. Not sure if that's how the switch is working, but... That's now our makeshift thing. Then I guess we can configure that, right? So, I mean, it's done. What we need to do is we need to set this one to GPIO29. I'm not quite sure, because now I put it on ground. We also need to include that, right? So this is now include filament run out. Let's restart that quickly. Oh, I see error. Great. Include file filament run out CFG doesn't exist. No, because it's called conf. Well, let's call it conf and restart. Okay. I'm sure if this is now showing up somewhere, but if I now click this, nothing happens. Should I have wired it to 5 volt? Or do I need to negate that? It doesn't give any errors or something. I think depending on if it closes to ground or 5 volt, you would need to pull up or not. Yeah, that's true. So at the moment it connects to ground. So I would need to pull down. It smells like this little like thingy. Let's add this little, I don't know how it's called, like this little hat. But it's also save and close. It doesn't offer me to restart. Can I rename that? Maybe it's because I called it conf, it doesn't do it properly. Filament run .cfg. And then conf can be. Let's quickly. Let me first paste that. Save and close. Yeah. So yeah, conf is the wrong ending. Delete, and then printer cfg. CFG. Let's restart that. Okay. Startup. Okay, so it did something. Let me see. What happens if I... No, it doesn't do anything. But I'm not sure if I broke the connection here. That's possible. I mean, now it's from ground. Query button. Oh yeah, that's a good one. Query button. How did I call it though? Unload button. Button equals unload button. Oh, it says pressed. And I'm not pressing it? Ha! Released. So it's inverted. But it still doesn't do anything. Let's do lights printing. Lights pending. But then let's remove that exclamation mark here. Now the lights should change. No, it doesn't do anything. Oh! It says unknown command when I push it in. Wait, let me clean it. If I push it in, it says lights pending unknown. So it does something. Oh, it's light pending. Light. Maybe the release just doesn't work. Okay. Ah! Turned on the lights when I pressed it, but the release is not. I mean, we can just move it into the press G code, right? If that works and the release doesn't work, then whatever. Like once you press it, it's not like a software button. You can move the mouse away and like release it. Like once it's pressed, you release it. Okay. I mean, it did the lights to red again. But then maybe the if stuff is wrong. No, but now it set the lights to pending. The question is, can I see this M117 somewhere? Ah, we can do that. Respond. That looks good. Then we can like debug it. Let's quickly add that. Press G code. not printing. Loaded. Unload. Not loaded. Load. And here we say printing. Let's see. Now it should like print stuff, I guess, in the console. Now we press it. And nothing. It's not listed here in the help. Filter. No, it doesn't do anything. Like it does the red light. Which is not in the release. Also, it's M180. I'm not sure. Like, let's see. Let's quickly try this one. Ah, unknown command response. Okay. Yeah, M118 or Clipper Native. Yeah, let's try M118. Then I guess it needs to look like this. Can I? Do that, and then I just remove that backtick, or like that thing. Let's see. Save and restart. You can use Command D to select multiple of the same text. Yeah, I'm not quite sure how this text editor works. Like, okay, let's see what we. Unknown command M118. Maybe it's like something I have to enable somewhere. That's weird. Let's try M117. I mean, M117 usually shows it on display, right? I mean, now it doesn't do anything anymore. Oh, here it is. Release. That's where it says that. It says release here. So if it says release, it's in the release G code, which also fits the light. So now let's move again this entire thing back to release. Let's say press. Press. Let's just do this one. Save and restart. Let's see. So it showed it up here. Press. I think it's just trolling me. It does whatever doesn't have the code inside. So something must be broken with that. The shortcuts are a lot like VS Code. Like you can hit Alt Up. Yeah, I'm not using VS Code. That's my problem. Okay, let's see. Well, if we comment out everything, does it do then the release? Maybe our like syntax is wrong with those ifs, and it just doesn't execute it, but it doesn't show any error. Press, release. Okay, so now it's doing press and release. So that seems like a syntax error then. Then let's uncomment everything except for our special if here. So that's the one, that's the stuff we had from the orbiter, basically. Oops. Oh, it was just so. Okay. Press, release. Not printing. Okay, so we were getting there. So now this is going into here. So now the question is, if it's now breaking, it's most likely this. I mean, let's just have the same condition here again. I'll just copy that so we know if it's the structure or this specific if. Let's see. Oh, it's doing something. It's unloading. So it's the if. So it must be this if. Maybe I should have let it at M117. So it must be something here. Maybe this is not the correct syntax. Let me Google that. I mean, we can also like save and restart, and let's just emergency stop, and we don't have to wait for Filament to unload. Okay. Printer. Ah, here, that's how it's supposed to be. Let's try that one. So it's printer and then it's like a array kind of thing. Let me just copy that again. So it's like this, and then it's run out sensors config name. Save, oh, save and restart. Let's see. Press, not loaded, load. Which is true. It's not loaded, it would load. Perfect. Oh no, wait, it is loaded. Let's quickly check. Filament detected, true. Let's see, like it should go into the unload block. Let's see if we can have it in true. Need printer dot? Wait, what do you mean by need printer dot? Oh, yeah, you're true. Yeah, you're right. Printer dot, that's why it's. Save and restart. That was too much copy paste. Decode button, unload, expected name or number. Okay. Oh, not dot. It's just printer and then that, right? Yeah, exactly. Without we need the printer, but not the dot. Let's see. Press, loaded, unload. Perfect. That's what we need. Yeah, I guess that's all we needed, right? So we can remove that. I'm optimistic I removed the debug comments. Yeah, we can remove that. I guess we can remove the press. Save and close. Maybe not sure. Yeah, however, was an example, exactly, yeah. It was like, just like it's an object and then like you have the array thingy, square brackets. Wait, did it now restart? No, it didn't. Now it restarts. Error. Great. Must be specified. Okay, so it needs the G-code press. Can it be empty? Seems like it can be empty, okay. Just needs to be there. Let's see. I'm not quite sure, it doesn't say now what it's doing. I guess it would now unload. I threw something off the cliff. Oh, okay. Nothing important. Let's see, so it should now heat up to 230. That's the only thing, like, you can't specify the temperature. Maybe there's like some magic that you remember the last printing temperature and use that. But at 230 is, I think, okay for all filaments. Like for PLA it's a bit too hot, for ABS it's a bit too cold, but generally it should work. And I guess then we have a winner here, right? Like, I need to print the part. I need to do a cable, of course, but it's like not a big deal, right? And then I have to swap out the foot again. But then basically that's all that's needed to be done. Just wanted to see now to unload, and then basically I would call it the win. Yeah, now it's doing something. Yeah, it's pushing it out. It's unloading. Perfect. Yay! And it's done. I mean, I need to work a little bit on the LEDs. That's very important, of course. But this is unload. Cool. Then I would call that mission accomplished. I'll make sure to publish that. Maybe not tomorrow, but like Monday or something. I kind of want to clean it up a bit. Add an icon. That's very important. And then install it and try it out. But I think it's a really cool mod. That's the first time I publish a mod for V0, so I really like it. Or you're headless. I was gonna say after it starts heating up, you should just change to it with this. But yeah, I'm headless, and I want to stay headless. Like I kind of wanted it this very beginning, but I really like it clean. Like this. This filament unload like routine basically. It's the only thing where I'm annoyed, because I'm not yet on the printer to start, like on the interface to start to print. I just want to change the filament, or like sometimes I need the filament for the other printer, so I need to unload it. I can also just snip it, but then you kind of waste a little filament. So it's like the only thing that I really want to have, like this button. Cool. Yeah, I get like also getting hungry. It's 9:30 again. So I would call today. Thanks for everyone who was here. There was a little bit like a different one with like fusion and like test prints. So it was a bit different than just building something. Yeah, let me know if you like that. And yay, that was my battery of the camera. So now we're on a webcam. Nice to have backup. Cool. Yeah, so that was basically it. Perfect timing now with the camera battery. And yeah, let me know if you like that fusion style thingy. Like, I have a couple more like that planned. I'm not quite sure how to like do that yet in a stream setup. But yeah, just give me feedback. Always happy to hear from you. And see you next week. Have a nice evening. Bye.